This is a really fun project that students can do. This is an example of problem-based learning. So this is about penguins. I teach this at different times during the year. Sometimes I use this during my energy unit, but I can also use it later on in weather, or I can use it in the spring as a review, combining the two that way as well. So what you're going to be starting with is like a little video to give some background information on these. In general, students think of penguins being in Antarctica, living in a cold environment, but this project is actually about the African penguin. So this little video that you will have gives some background information about these penguins that live on an island that's much warmer, but because of climate change, it is becoming more and more difficult for the penguins to live there. Their nests are not very well protected, so the eggs are overheating, and the penguins are also having to leave for longer periods of time to fish farther out because of the depleted fish supply for them. Anyway, the challenge then for the students is to create a habitat, a little nesting box, if you will, to protect these eggs. You're going to have all kinds of materials. You've got bubble wrap. This year it is yellow. I was surprised by that. Cotton balls. This box, by the way, will be plenty for you to use for all your classes for at least 1 year and probably more than 1 year. Other materials in here: red, white, black, and green pieces of foam, like the fun foam that you can use for crafts. The same colors of felt, already pre-cut. So this is a kit that's already put together, but obviously it's easy for you to get these materials and make more. The same 4 colors of construction paper. Then these little tiny craft sticks, they're little baby-sized popsicle sticks. And then both aluminum foil and Mylar. I find my students don't really know what Mylar is, so you might have to talk to them about like birthday balloons and things that are in this. But there are a couple ways you can do this. Sometimes I let them test these materials first by putting a piece over a thermometer, for example, and letting it sit under light for 5 minutes to see how much the temperature changes. Is it a good insulator? Is it a good conductor? That gives them a little bit of background information on these materials, especially if they are not likely to have had experience with some of these, and you'll know your student population better. But then their challenge is to use these materials, build a little house for your penguin that could be a nesting box, and then you're going to see how effective it is at protecting the penguin. So I have them design it. They have to draw it out, decide what materials they're going to be using ahead of time. As you can imagine, you can end up with a disaster of mess and wasted materials if you don't do that, so that they know what size their house should be. This is an ice cube tray. I've made a set of plaster of Paris penguins for you. So these are reusable from one class period to the next, and obviously you can make more if you want. So you have a little penguin. The house the students build needs to allow this penguin in and out of a doorway. Other than that, you can set whatever restrictions that you want. So they're going to build their house over a day or two, however long you have. You can make this take as long or short as you want. Just for managing materials, I have decided that I have them do in an igloo store. So they fill out an order form. I usually give them a budget. You can do it, everybody gets the same materials. You can give them a budget. You can do whatever, but it has saved me time and mess to let them shop at the igloo store. This is an online store, so they put in their orders and the next day they receive it already packaged in a Ziploc bag, and that just simplifies everything. Less mess, less waste, and less headache for passing things out in class. So after they build this, then you're going to have them test the model. On the day of testing, instead of using these plaster of plaster of Paris penguins, you're going to use ones made out of ice. That will let you know if your habitat indeed is protecting your penguin adequately. So you'll, at that time, substitute an ice cube version instead of the plaster of Paris. In order to find out how successful it is, you're going to first weigh your penguin, your ice penguin. This is a good time to talk about zeroing out your scale, because I usually put a little container here to help catch any water as the ice cube melts. But first you're going to have them weigh the penguin before it goes into the testing environment, and then again at the end to see the percentage change of that. So let's go, I'll show you the testing environment for that. Okay, so the connection to energy comes in this piece, because we're going to be seeing heat through conduction, convection, and radiation. It's a good summary at the end of the energy unit. But again, because you have your tie-in with climate change, you can teach climate change with your weather unit and use this as a connection for that as well. So this is just a Rubbermaid container. You're going to want to line your container with aluminum foil, and you're going to put black construction paper at the bottom. So you're going to be hoping that that black construction paper helps absorb heat from radiation. You're going to have the reflection here. You have a fan that's going to produce your wind current, so you have a little bit of air movement with convection. So again, radiation and convection. To get conduction, you will have these hand warmers that to put underneath the construction paper or underneath the container itself, whichever you would like. Sometimes I use these, other times I use just a heating pad and put that underneath. That way I can turn it on and off, and I can be sure that it isn't losing heat by the end of all of my classes. So I would suggest 2 or 3. Sometimes you'll have to put these on ring stands depending on how well you can get it to hold to the edge. Some years I have great luck, other years not so much. But you're going to set all of these things in here. Then after the students measure the mass of their penguin, they're going to put it inside their house, put the house down in here with the lights on. After 5 minutes, then you take them back out and you remove the penguin and you take the mass again, and you're looking to see what percentage of the penguin survived. And there's a little sort of grading sheet that goes along with that, so they know how successful they were. If they have not had a lot of success, as a class we usually look at everybody's home, and the ones that did not do well, some of them want to rebuild, obviously, to get a better grade. So you can either do that, or you can just have them write a summary of what they would do if they were going to make another one, to see if they can figure out what the problem was with the one that they designed. Some of them are much more into the fashion aspect and less of the scientific. One note, you are receiving light bulbs for your lamps. The ones that you are being sent are LED. I'm not sure how much heat you're going to get out of those. So I still have normal light bulbs, incandescent light bulbs in my house. So I frequently bring those in. But you just be aware that those LED lights may not have as much heat, so they may have a higher success rate. You can usually put 2 or 3 houses in here at a time. So this is a time where I have students bring this and then work on something else at their seat as we're testing through the process. But they have a great time with this, and it's a good review of the conduction, convection, and radiation, because all parts are there. And students are very invested because they're trying to be sure that their penguin survives.